All right, as usual, if I have any mistakes, I'll put it in the description below or in the pinned comment. Studies have shown that foods rich in compounds known as flavonoids help lower blood pressure. Researchers conduct a study to investigate whether there's a greater reduction in blood pressure for people who consume dark chocolate, which contains flavonoids, and people who consumed white chocolate, which does not contain flavonoids. 25 healthy adults agreed to participate in the study and add 3.5 ounces of chocolate to their daily diets. Of the 25 participants, 13 were randomly assigned to the dark chocolate group. The rest were assigned to a white chocolate group. All participants had blood pressure recorded in millimeters before adding chocolate to their daily diets, and again 30 days after adding chocolate. The reduction in blood pressure before minus after for each of the participants of the two groups is shown in the dot plots below. Determine and compare the medians of the reduction in the blood pressure. Okay, median's the number in the middle. And let's see, dark chocolate had 13 and white chocolate had 12, I believe. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then there's 13 here. So the median, as you sorted them, you want to find the median. So they want to determine the median. So I want to go for when there's 13 numbers, what I like to do is I like to eliminate top and bottom or count to like 7. So I would say not that one. Not that one, not the next highest one, then the next highest one, and then you kind of get to the middle, there and there, there and there, and so this guy's the middle one, and he's at 7. So the median for dark chocolate is 7, and let's do the same thing for white chocolate, highest and lowest, because I'm just trying to find the middle guy, right? There, 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 there. Okay, now I have 2 left in the middle, so what do I do with the median when there's 2 left? This is kind of mean, but they don't usually test you on this much. You just take the average of those 2 to find the one in the middle. So I have 2 left, so I can't eliminate both, so the median is 0. So the median for dark chocolate is 7, what is this? 7 mmHg. Is that verse compared to 0 milligram mmHg for the white chocolate group. So my conclusion is the median is, so, the dark chocolate had a higher reduction. So dark chocolate had a higher reduction. Dark chocolate median had a higher reduction in blood pressure compared to the white chocolate group. So just to be clear on that part, when you're calculating the median and you have 2 values in the center, you take the average. In this case, the average would be 0. Okay, so that's why I got those 2 numbers there. Okay, the researchers found the mean reduction of blood pressure for those consumed dark chocolate is 6.08 millimeters, whatever, I'm just going to go, and 0.046. Okay, one researcher indicated that because of the difference in the sample means is 5.66 is greater than 0, there's convincing statistical evidence to conclude the population of mean blood pressure reduced is greater than those for who consume white chocolate. Why might the researcher's conclusion based only on the difference not be necessarily true? Because the difference might just be random. Okay, that's why we run a p-value test. That's why we run a hypothesis testing, is because the difference alone could just be statistical luck. And I would be more specific here. So actually, I'm gonna switch to typing maybe a little bit on here. I gave myself room to type. Should have done that to begin with. Okay, so what do I mean by that? I would be a little bit more specific here. It could be that there is no difference, but the dark chocolate group just happened to have more reduction in their blood pressure by pure chance based on their random assignments to the group. That is to say, like, if you had flipped the coin differently and they had been put in the white group might have shown a larger reduction. So there's no way you can know that for sure. That's why we do p-value, probability. That's why we do null hypothesis and all of that. So a simulation was conducted to investigate whether there's a greater reduction of blood pressure for those who consume dark chocolate and those who consume white chocolate. The simulation was conducted under the assumption that no difference exists. The results of 120 trials of simulation are shown in the following dot plot. Using the results of the simulation, determine whether results from the 25 participant study provide convincing statistical evidence at a 5% level of significance that adding dark chocolate to a daily diet will result in a greater reduction of blood pressure. So we observed, let's see. Okay, so we're using these numbers. We observed here a difference. So this is a simulated difference in means. So the difference in mean we saw here was 6.08 minus 0.42. So we saw a difference of mean at 5.66. That's what he was saying here. So the mean of difference was 5.66. So we want to see if the difference is 5.66 or greater. So like 5.66 is about there. So how many, in our simulation, how many times did it occur that we got that much or larger of a reduction? Was that occurred, so 5.66 or higher reduction occurred 3 times out of how many? Out of 120, which is a incident rate of 0.025, okay? So which is 2.5%. So 2.5% of the time, just by pure chance alone, did we get values where the mean reduction was 5.66 or larger. That is less than 5%, okay? Which is less than 5%. So there's enough evidence. So we would say, yes, there's enough evidence that the reduction is not due to chance. And then I would ultimately say that that the reduction is not to, and consequently the adding white chocolate, the adding dark chocolate will reduce blood pressure. Now, this is a simulation, so you don't actually need to justify anything on the normality conditions because we're using simulation results. I don't know if you should write a null hypothesis. I might write a null hypothesis. I don't know if that's required here. Null hypothesis is that there's no difference. I would say, yeah, like mu1 minus mu2 is equal to 0, or mu1 is equal to mu2, and I might define the variable that mu1 is less than mu2. Honestly, I don't think I would write this, and I don't think it's necessary to, because it's simulated difference. I think the explanation is sufficient. So if you didn't write the null and alternative hypothesis, I think that's okay. But, you know, if you wanted to be complete, you might want to put that. This is the dark chocolate, or the reduction is greater. So we'll say this is the blood pressure. I just don't want to write it because I'm lazy. Okay, but you may want to include that.